It's not here. All right, so we're working on, we're kind of continuing our rotation around an axis called angular motion is what we started with. So now we're doing the kinetics behind that angular motion. I don't think my thing worked. I killed it. I thought that was working. Oh well. All right, so angular kinetics is probably easiest thought in the terms of gymnastics because you do a lot of in tumbling, backflips, around the high bar or the uneven bars for women. There's a lot of momentum things there that work, and then we're just going to take that and apply it to other sports. So angular kinetics is all about the rotation and all the things that go along with that. An object is usually the human rotating around a pivot point, and that's called the term angular. So all these terms here you just need to know for your quiz. The rotation can be an external endpoint, like the gymnastics bar, or it can be an internal point, such as your own center of gravity. So like a tumbling pass, a back tuck, you're rotating, you are the center of gravity. So gravity fundamental principles. So gravity can be used to cause, initiate, or limit rotation, depending on how you use it. So when a pole vaulter drops from above the bar at the very top, the gravity accelerates the athlete towards the pit as they land. So if an athlete clears a bar of, we'll say 20 feet, rather than 15 feet, the extra distance gives the earth more time to accelerate the athlete on the way down, which means it's going to hurt worse if they miss. So the farther you fall, the harder it hurts. I've actually heard it said that cheerleading is one of the biggest impacts in all of sports. And that's because you can toss a gymnast, those little tiny 5'0" girls, you can toss them pretty close to 20 feet. Our gym at Sunnydale, when I was coaching there, the college team would come and their 4 big college guys would toss a girl and they would easily touch the ceiling. Gym masters would go to Highland Academy where I would do basketball camps in the summer, and they had beams across, and like a rite of passage at their Acrofest there was to toss your flyer and have them grab the beam. And I'd even seen people that put like a GoPro on their head so they could see their hands grabbing and then look around and then drop. You have to pull your legs up before you drop, though. You don't want to drop straight down. So it could be something as simple as just jumping off of something, moving your center of gravity. So this is me at a place in Arizona. So I have to lean forward in order for my center of gravity to go out over top of this little cliff thing. Oh, it was a blast. It was just hard to swim in that. It was like 105 degrees, but the water's like 60. So it's like, it takes the breath out of you for a second, and it feels really good. But yeah, you have to move that center of gravity so that gravity can then take hold. And technically there was angular momentum because I jumped outward, and that was an angular motion to go out. So the fundamental principles here. So you'd have your velocity in the first second. You go about 16 feet in the first second. So you would be going at 9.8 meters per second. In the second second, you're going to go 19 meters or 64 feet. At that point, you're going to be going about 20 meters per second, about 43 miles an hour in the second second. In the third second, you're going to be going 64 miles an hour. You're going to travel 43 meters in that third second. And in that 4 seconds, you hit the water going about 90 miles an hour. Anybody ever jumped off a cliff that was high enough to go 4 seconds? Huh?
That'd be 400 feet, right?
No, it looks like 256 feet.
Oh, yes.
You've jumped off a 250 foot? Whoa!
No, it was it's super deep though.
No, I know that.
It's like a waterfall.
That same place I showed you in Arizona, they had a cliff that you could jump off that was kind of underneath a bridge. And when I jumped off of it, and it was probably, I'd say 40 or 50 feet at most. It wasn't super high to me because I jumped off 100 plus ones in Tennessee. This one, I hit my feet on the bottom, and it was like big rocks and stones. And when I came up, I'm like, if you're my size, you shouldn't be jumping because you're going to go straight down and hit something. You don't want to. Sometimes when you jump off of a cliff, you'll go, and I don't know if you've ever experienced this, your feet actually sink into like sludge at the bottom.
Oh, it was way deeper.
Yeah, this one was not deep enough. So like the sludge and the rocks that my feet went into, I'm like, yep, I'm done. I will not be jumping off that again because I don't want to get stuck on the bottom of it. Because no one coming to get you if you jump off that and you get stuck on there. So, does gravity, so tell the person next to you, does the uniform acceleration of a springboard diver mean that a parachutist in free fall accelerates continuously towards the earth? So a diver and a parachute, are they the same? Why or why not?
Do you mean the
Well, like in this one, it had kind of a uniform acceleration of a diver. Does a parachutist have a uniform acceleration?
oh yeah.
All right, this one says a parachutist will free fall at a constant velocity till about 125 miles an hour, because eventually the air resistance will, they call it terminal velocity, like however fast you're going down and how much resistance you get of the air coming up, eventually those will even out. Have you ever heard someone say, don't toss a penny off of the Empire State Building?
Yeah.
Why? Huh? How?
Because of the speed which is falling at, and it's like a sharp new object. They said that about that, and like even like the apartment buildings that I live in New York, it was like those stuff about and that's just about 13 floors.
I've heard conflicting things on that one because have you ever tossed a penny? How does it usually fall? They usually do this number. They kind of go flat and alternate back and forth. So like, will its terminal velocity actually, if it would actually fall straight down, yes, it probably could kill somebody. I don't know if it actually does. That would have been a really good Mythbuster episode. I don't know if you guys ever watched that show. I love that show. Mythbusters was so good. All right, so back to sports here. So if we collectively add up the parts of the human or the object, that you can usually find a balance point of them. So the athlete's body has different substances in it. Y'all learned that in exercise phys. So your athlete can shift their center of gravity from one position to another to give themselves the optimal performance they want to do. And I think I've said that in this class that the Fairsbury flop, where you're jumping backwards over, your center of gravity is actually lower than the height of the bar because that's where your head and feet are. So that's a really good manipulation of an athlete's center of gravity. So a person could, if you're standing still, if you put your arms up, the center of gravity goes up. If you put your arm out to the side, your center of gravity goes to the side. All makes sense, right? All right, another partner question. Here are 4 different people. Rank them in their center of gravity from closest to the center to the farthest from center. Talk to the person next to you, rank them. You can do it by color or you can do it by their names there. Tough to see the name with this thing in the way, though. G, are you gonna be good walking like a football field or so? Okay, so you get to chill. That's what I would do.
I'm just testing it, dude. I'm just trying to see where my center of gravity is.
All right, so here's what I came up with. Mike is the closest because all his limbs are in. This one on the end. These are the farthest and the furthest and the center are the easiest. It's these two that are a little more difficult because where this foot is compared to the arms, because this one's actually got elbows, so they're kind of like here. So I have this one and then this one. And really the way the big key to this one, think of this as a figure skater spinning. Which one would be spinning the fastest? In whatever position they're in. This one would be spinning the fastest. This one with their arm and leg out would be the slowest. This would probably be the next slowest. Yeah. All right, so the important factor for maneuvering any center of gravity is how you move your limbs. So if you stand up erect, I call it extension position. Your legs moves forward, then your center of gravity shifts forward in that direction. So I stand erect. I move my foot forward, my center of gravity goes forward, therefore I lean and walk forward. Sounds simple, I know. The distance that the athlete's center of gravity shifts depends on how much of their body mass is moved and how far it is moved. That is why when Shamar drives the lane, everybody gets out of the way, because you have a center of gravity and a mass coming towards you, and you get out of the way. I would not take a charge from Shamar. I have no problem taking a charge from most people, but when they're bigger than me, I don't do it. So other ones here. So this one's interesting. All these videos that I found, I got another one later where they show kind of all the biomechanics. For now, just look at this top left one here, and they're just actually tracking his center of gravity as this video goes. Notice as he goes in the air where the center of gravity moves. I so want that whole setup there. That looks really cool. All right, so a center of gravity could be outside of the body when you're doing like a pike position. It's very difficult to spin doing a pike position compared to a tuck. Another place where you could shift the center of gravity outside your body would be like a back walkover. This girl is way too flexible. So here's some of my gymnasts from years ago. So watch, so there's one in green leggings and one in kind of like, I don't know, reddish leggings. It's kind of hard to see there. Watch those two as they do their back walkovers. One of them makes it and one doesn't. Short. All right, so watching the girl on the right there in green, when she starts her back walkover, she shifts her hips forward just a little bit and then actually bends her knees to try to be able to spot the ground behind her. So moving her center of gravity over her feet so that she can get to the point of putting her hands on the ground. The one on the left in the red, she actually bends her, you can actually watch her shift her hips forward to get that center of gravity forward. She has a little more bendable back, and so her hands are a lot closer to her feet. But then the kick over here, she doesn't get enough kick to get her center of gravity back over her hands and shorts it. This was supposed to be a flexibility routine. All right, so a little more on center of gravities when it comes to some of your sports equipment.
A good point of balance is one of the sports dictated function of the sword. The small sword is specialized entirely on the thrust. As such, its point of balance is very close to the hand to get a nimble tip. This long sword has competing demands of cutting and thrusting, although it favors the cut. As such, its point of balance is much further out. This gives it more heft behind its swing.
So depending on what kind of, how many of you guys have taken the fencing class? You guys seriously need to take that class. It looks like so much fun. So there's other times where you can shift your center of gravity. Jiu-jitsu uses it quite a bit here. Judo, sorry. They do a lot of center gravity movements. So this guy here, I mean, you don't have to be stronger. You just got to know how to use your center of gravity compared to your opponents to get them to flip over top of you. A runner, right before they sprint, they actually put all their center of gravity is actually in front of their hands in those starting blocks. Also, the starting blocks raise their feet off the ground. And something I was told about Jamaican sprinters, they actually put their feet really high on those starting blocks to get even more of an advantage. And then other track and field events, we kind of talked about that too. So in some events, the athlete inflates for a short time, and that path is set at the takeoff. And then when you combine a vertical and horizontal forces at takeoff, that's going to give them their trajectory. The Earth's gravity is going to pull them back down, and then so their jump is going to be some sort of a parabolic shape in some way, shape, or form. Can a basketball player float in the air? Huh? Some? Why? Why do you think that? So I don't remember which thing I saw talked about that take your like Kyrie Irving. Oh, didn't he go in between 3 different guys yesterday to make a shot? He like started over here and he's like, no, and he flipped it out here over the front of the rim against the Clippers. But when you looked at like Michael Jordan jumping from the free throw line, that's the one that they were analyzing, and they're like, it just seems like he just stays up in the air longer. And it's actually, his head does stay straight a little longer than it should, but his center of gravity is going down, and his whole body's actually stretching. Arms, legs, everything is stretching out, so it just looks like he's hanging in the air longer than everybody else. So like when you looked at that Kyrie Irving play, when he's hanging for a little longer and everybody else is kind of going down, it still seems like he's hanging there. It's because he's actually elongating his body to try to get to that point. And we'll do a jumping lab in a couple weeks. So we get to all that to talk about angular momentum. So angular momentum describes the quality of motion that a rotating athlete or an object possesses, is also the product of its time, so of the angular velocity. So there's several things that make up an angular velocity. You have your mass, how that mass is positioned around the axis, thinking of a figure skater spinning, and then the rate of rotation. And so that's the angular velocity we talked about last time. So thinking about increasing that momentum, I think I got a baseball bat in here. Yes. actually a very small bat. So batters can, if they want to, choose to have a heavier bat. So if you add mass to your swing, you can probably hit it farther. Does that seem to make sense? So they say, now I don't know this for sure, I've never actually held it, the wooden bat that Babe Ruth used was like a third heavier than every bat that any Major League Baseball player uses. So he just had so much mass, and when you watch him swing, he has a whole lot more like body motion with his swing, where nowadays people have a whole lot more. They swing first, and they have this lag in their swing, and then they flip their hands at the end to get as much velocity out of it. You can't do that when the bat's that much heavier. You got to get that bat out a little earlier instead of hold, and then hit. You can extend your body during the strike. You can either do it really late, or for like slow pitch softball. Anybody playing softball in here? Played against a couple of you. It's actually better in slow pitch to get that bat out away from you first to get more velocity on that slow pitch swing so that you can get actually a longer swing arc to get more power. Now, you guys, this coach, when I pitched to him, he always wanted it high and inside, and he would get that baseball swing and that slap at the end. He'd always hit it down the left field line or center field. He never hit it to right field the whole time we played. So something I struggle with, and I had a girl in my last game that I played over in intramurals. How do you get someone who doesn't have a lot of, doesn't know a lot about baseball and hasn't done a lot, how do you get them to actually hit the ball? What do we usually tell people to do? That's one. What's the other one? What's something that we could, let's go with physics, that you can do? What do we tell people to do? Choke up. Why do we tell them to choke up? Huh? More control, yep. Have you ever tried going from a tennis racket to a badminton racket and had a hard time hitting it? The farther away the object is from your hands, the harder it is for you to have the coordination to hit it. So that's why when you have a beginner, you tell them to choke up so their hands are closer. And then it actually is closer to a tennis racket length compared to a golf ball or golf swing kind of length. That's one reason. Oh, yeah, and I had this one. So when a female, usually you want to find them the lightest bat you can, and then you tell them to choke up on it so they can swing it as quickly as possible and have the most coordination. If you take a guy like, let's say, Shamar or brain is just not working today. Big, strong people. I'm sorry. It's one of those days. If they're using the same super light bat, they actually will crack it. We had a bat that I bought I think it was at Walmart on clearance. We called it the Queen of Diamonds. It was a super light, probably girls softball bat. And after like 2 years of using it, pretty much every class period for 2 years, it actually cracked because all the guys were hitting it too hard. So I have actually had a bat break. So athletes need to find a balance between mass, distribution of that mass, and angular velocity. Sometimes bats have a big, thick barrel at the end. This is more of a softball bat here, where it's all about the same from here to here. Most baseball bats for like Little League, it's going to end up like really thick on the end and then taper down quickly. So another term you're going to need to know is the conservation of angular momentum. So the principle of conservation of angular momentum is the rotary version of the first law of inertia. So Newton's first law, which tells us that the mass on the move will continue moving in a straight line until it has oppositional forces to do so. So if you're spinning around your body, you'll see people that will forget to hold on to the bat, And they'll swing it as hard as they can, and there's so much momentum, they'll either let go of it and it goes flying and then hurt somebody. I've actually had a student, they were okay. They swung. I told them, if you want, you can let go with one hand. He let go with one hand and then stretched his arm out like this, and it came around and bonked him in the back of the head because he didn't realize the angular momentum of the bat would keep going. He was fine. So basically, spinning objects will continue spinning until something stops them. All right. We're going on a field trip. If somebody could give G a ride over to the elementary school, is where we're going. Yeah. We're going on a field trip. We may not finish this lecture today, and I'm okay with that. You can leave your stuff here unless you just want to carry it with you. No, we got 20 minutes. We might get a little more. It take 20 minutes to walk over there? Oh.
And then back.
And back. Might be hard to get G there. Let's go.